Good afternoon, everyone. It's our absolute pleasure to welcome you all in Assisted Reproductive Technology Skill Development event here at IIT Hyderabad. We have gathered today in pursuit of knowledge, innovation, and progress to ever-evolving world of clinical embryology and reproductive medicine.
This event brings together some of the brightest minds in the assistive reproductive technology who will share their expertise, research, and insight on the cutting-edge developments that are shaping the future of fertility care.
Through insightful discussions, engaging presentations, and meaningful collaborations, we aim to bridge the gap between skill development, training, and competency assessment in this field.
As we commence this esteemed gathering, let's begin with the tradition that signifies knowledge, wisdom, and enlightenment, the lamp lighting ceremony. The lighting of the lamp is a symbol of dispelling darkness and igniting the flame of learning and innovation. I would now like to invite our distinguished guest to come forward and light the lamp, marking the beginning of this insightful event.
I request Dr. Renu John sir to felicitate our esteemed chief guest and speakers for today. I invite Dr. Lotte Strobeck to come over and accept the felicitation by Dr. Renu John sir. I request Dr. Paul Heitel to come forward. Now I request Dr. Rohit Gurgutia. At the last, I request Dr. Vijay Mangolia to come forward.
Now, I request all the dignitaries to proceed for the inauguration of Assisted Reproductive Technology Skill Development Center at CfHE IIT Hyderabad, followed by the facility tour.
Sandeep Karunakar, a highly experienced senior IVF consultant at Apollo Fertility, Hyderabad. With over 2 decades of expertise in reproductive medicine and embryology, Dr. Sandeep has been pioneer in innovative fertility treatments, including ovarian cortex transplantation and integration of AI in reproductive healthcare. His vast contributions to the field make him a leader in shaping the future of clinical embryology. He will be speaking on topic clinical embryologist in Indian IVF sector and evolving profession of high complexity.
Thank you. I'll manage. This date actually holds a lot of importance in our field. 25th of July, 1978. Those associated with ART would know what it actually means. It was the day when Louis Brown was born. She not only stepped into this world, but along with her, also stepped in a new field in science, that is reproductive technology or assisted reproductive technology as we know. Louis Brown was very beautiful on birth. Beauty not only to the parents, but also to the other parents, that is Bob Edward, Patrick Steptoe, the gynecologist and the embryologist respectively, who actually got her into life, and not to forget the key person in this entire thing, that is Jean Purdy, who was a nurse but doubled up as an embryologist in this case. So, from time immemorial, embryologist has been a very key player, and as we can see out here, despite being a key player, she actually doubled up on a role. She was actually a nurse who also did embryology. Similarly, India was not too far behind. Just about 3 months later, we had the first so-called unofficial baby in terms of Durga. She was born in the month of October. The first official birth or scientifically documented birth we all know was under the aegis of Dr. Indra Hinduja, and this happened in August 1986. That girl today has become a mother. The center figure actually is actually I don't know why the screen is not coming well. Could the tech guys come here? The center picture actually is of the mother who gave birth to her daughter through cesarean section. Since then, a lot of technological changes have happened, and a huge amount of people have joined this bandwagon of becoming so-called reproductive medicine specialists and also embryologists. So if he can do it, why can't I? This evolving profession, or this evolving sub-profession, I would say, has a lot of complexities, and I would try to decipher or try to look into the reasons as to why it is so complex, and also how, as a training institute or as a teaching institute, we can slightly ease it out. I'll go through a lot of things starting from the role of what an embryologist generally does, how things have become complicated or in India, how it has actually gone down the line, and what actually made me happy when I got a call from Dr. Renu John. To introduce the entire topic, it's been about 4.5 decades and still counting. Undoubtedly, it has been a huge progress in this small niche field of reproductive medicine, but has the process been simplified, or is it getting more and more complicated as time goes by? The pharma industry has developed right from gonadotropins being derived from mares and pigs. We have now reached to a level of purity where we can actually weigh the gonadotropin and tell exactly how much international units or what activity it actually contains. The clinical part has also progressed well. The standard protocol from long agonist protocol has moved on to Shanghai protocol, double stem, better triggers are now known. Even the nomenclature has changed from ovarian stimulation to ovarian hyperstimulation, and now we call it ICOS, or individualized controlled ovarian stimulation. Lab was not far behind. From casks and inverted glass bottles where we used to culture, we have gone into monitoring embryos right from the comfort of a kilts, as Sanket would understand or would agree with me. With time-lapse imaging, he can sit, before he even has his first cup of Earl Grey, he could actually tell what is the stage of the embryo today. Not only that, he can sit in his comfort of his home and tell, oh, the incubator 3 is actually showing a slight increase in temperature. We rather send this service team there. A lot of progress has happened on that route too. Andrology, that is the male part of gametes, has also progressed a huge lot. Right from simple semen processing, we are now talking about individualized sperm selecting methods to actually pinpoint and pick up the correct sperm, which will give us a better outcome. So, has this been a slow metamorphosis, or has it been an upheaval of change? A lot of things are still knocking at our doors. Vitrification, we knew. I mean, in fact, today in the lab, I was actually talking to Dr. Rohit, and we were seeing one of the old slow freezers. I mean, in my decade of short experience of about 2 decades, I mean, it has actually moved from slow freezing, and now we are talking about ultra-fast vitrification. AI is knocking our doors, microfluidics is there, there's concept of functional microscopy coming in a big way, and also intervention genetics, which is also happening. That actually complicates the role of an embryologist. Initially, we used to think of him as a biologist or a cell culture specialist, but that's not all. He becomes a micromanipulator at times. He has to manipulate the oocytes and embryos, and not to forget the macro manipulation that he has to do at corporate levels too. A cryobiologist, a quality manager, he has to look after research because he is the main data collector in our setting. An administrator, a logistics guy, and not to forget a troubleshooter too. He has to check which equipment is faulty. He has to detect the fault, check the fault, and possibly do R1 or the level 1 repairs too. Not forgetting networking and be a student throughout life and a teacher to his students too. When it comes to medicine, we think of this multifaceted talent exists only in the hands of an anesthesiologist, but now I think an embryologist is also taking over that role of Ma Durga, where you need more than one hand or one pair of hands to actually complete the work. So, with increasing roles, increasing responsibilities, we need increasingly capable embryologists and who has a knack of keeping up with the rapidity of evolution. So if an embryologist today doesn't conform, he is set to crumble under the pressure. So how does one cope under such devastatingly or fast-changing structure of embryology? Well, I think the first thing that we actually need is a structured basic training. And the second point I think is the most important thing. A skill which has knowledge backing. Unfortunately, even me, when I actually started doing my first ICSI, I didn't realize what is the biomechanics behind the entire ICSI procedure. So the skill acquisition should be knowledge-based. Obviously, he must today have a research mindset. He should understand the equipment, not only what it does, he should also understand why it does and how it is doing the same thing. And as I already said, problem detection, problem solving. He has to be a Sherlock Holmes as far as repair is concerned. He should have access to research literature and should be open to technology incursions. Yesterday I was in the National Conference of SR, and where I had a slightly old-time embryologist who was saying AI does nothing to embryology. But unfortunately it is not true. AI does a lot of things to embryology, and somehow I beg to differ with those senior people too. So, without, let's say, integrating everything together and the blessings of the correct guru or the correct institution, it is definitely going to be a Herculean task in the near future for the embryologist. Not only that, the rising complexities of the day-to-day, of the changing day-to-day life, which has made the entire system of embryology from a simple hierarchical system to a total network of interrelated or interdisciplinary sciences which are involved, makes it even more challenging. Also, the changing nature of disease adds its own complexities. The disease itself has changed over a large period of time. It is now not only simple infections which cause infertility, There are genetic diseases which have been detected, and so on and so forth. Even we know that COVID has also changed the entire specter or the entire visualization of infertility per se. Notwithstanding all these problems, we have a slightly unparalleled progress when we talk about the two arms of reproductive medicine. Let's talk about the clinical arm first. Clinical arm has actually progressed since quite some time. Even in the early 2000s, we had structured training program for doctors, for gynecologists. And now we have also 3-year courses doling out MCH degrees in more than, I think, 5 institutes, if I'm not wrong, as of now. But unfortunately, embryology has not been so kind to the juniors. There have been few or very little training centers till the last decade. And of late, after the ART Act has been passed, there has been a sudden mushrooming of MSc embryology centers, and with very little infrastructure. I'm sorry to say, but most of them, or rather most of them, are not even attached to a clinic or even a wet lab or an animal lab. So there has been a lot of disparities. I did MBBS for 5.5 years. 4.5 years was mainly theory. But what was most important, and I think the most fruitful part of my MBBS training, was the internship, wherein we connect the dots, connect the theory to practical, and then possibly assimilate the two and send it ahead. So what I mean by this is, if an embryologist doesn't have hands-on training, how can he be a good embryologist? There has been disparity between India and abroad. Let's compare Indian standards with European standards, CfHE or ESHRE. ESHRE defines what exactly the degree of the embryologist needs to be. They not only define the paper qualification, but also tells us how many hours or how many ICSIs he must do, or how many procedures he must have actually overlooked. There's a defined hierarchy. There is a senior embryologist. It defines the role of a senior embryologist. It defines the role of a lab supervisor. It defines the role of an andrologist. It defines each and every role in the entire workspace of the IVF lab. Accreditation is necessary. The embryologists, they have to go. And as I already said, the roles are well defined, be it either side of the Atlantic Ocean. When it comes to India, unfortunately, just a paper qualification of MSc embryology is good enough. There is no quantification of the work that the person must have actually done before he actually sits on the stool of the embryologist. There is no hierarchy. There is no accreditation. So everyone who gets a degree is a great embryologist. And 1 year down the line, he becomes a senior embryologist. There are no defined roles. That is the problem, or rather, that is one of the side effects of the ART Act that has been passed in 2021. So, since there has been no determined practical competence level, it has led to a mushrooming of MSc courses, and sadly, without much hands-on. And most of these courses, unfortunately, are still held in absentia, if not online. Two-sided losses. The students, they have a degree, but they're not confident enough to actually knock the doors of a clinic and say, yes, I can do what you need me to do. The ART center, I'm pretty sure Dr. Rohit will agree with me. Many a times I have employed embryologists and found that their CV is not akin to what they can actually do on ground. So why can't we act in this huge country of ours, which possibly will be doing at least about 7 to 10% of the IVF cycles of the world in the near future, have a center which can accredit the embryologist per se. Okay, I mean, let's say you give a score of 10, this person stands at 8.5, this person, despite the same degree, will stand at only 4.5. So we need a center which can help the center, I mean, it helps both the sides, the students as well as the employers, to pick up the correct candidate for the correct job. So the need of the hour, it's been changing. I have a defense background too, so I'll tell you a small story from the Indian Air Force. So the top photograph is of a NAT aircraft which was used in the Indo-Pak War. As you can see, the cockpit is pretty simple. The 3 cockpits below are from a F-22, if people are interested, Sukhoi 27, and the last one is a Eurofighter. Okay, now you know the panels which are there. The planes are getting complex. The maneuverability is complex. So what do the Air Force do to, change, welcome this change of technology? So we have better entry criteria. today, no Tom, Dick, and Harry can actually become an fighter pilot in the Air Force. Only an engineer can become a fighter pilot. So they have changed the intake criteria. The planes are flying at 5G, that is 5 times the gravitational pull. So you have stringent physical standards, physical training. You have advanced academics which are imparted to these people. So they actually say flying is easy. Learning from the books is more difficult if you talk to a pilot. There is diversification of the source of knowledge and integrating that into the same person. Also, today you always fly with a co-pilot, and the co-pilot is not living. The co-pilot happens to be artificial intelligence. There is every single aircraft which is involved in a dogfight cannot win it without having AI as its co-pilot. So much so, the US Air Force has said the last fighter pilot of our country has already been born. So they are not talking of drones, they are talking of fighter pilots which carry the full payload, fight a dogfight, bring down enemy aircraft, drop a few bombs in the country, over the countryside, and return back without loss of life. When they can advance, when they can adapt, why can't we? And IVF or reproductive medicine per se, be it clinical side or be it embryology, we can absolutely improve the entire system by integrating AI into the system, into our daily scope of work. Today the lab looks full of machines, full of people too. Tomorrow it will be one person looking after the lab, and that lower diagram is from conceivable IVF, wherein you just have to feed the follicular fluid and the semen unprepared, and you can decide what you want. You want a day 3 culture, you want day 5 culture, you want a frozen day 3 embryos, you want frozen day 5 embryos. The machine will do it for you. One person, Sanket, thanks to you, you will be sitting in the lab and doing this, possibly after 20 years or so. So need of the hour is possibly assess the situation, imbibe the changes, adapt and evolve. Because if you don't do this, if you don't do progress, you are going to perish undoubtedly. So as a training institute, we would want to provide the basics, have a good set of training material available, and then spice it up with the advances, that is AI, possibly a lot of micromanipulation, a lot of integration with R1 repairs, and so on and so forth. So what made me actually happy when I got a call from Dr. Renu? Firstly, of course, undoubtedly, it was a call from IIT, and sir has been with me for quite some time. We have been interacting. And the institute also includes high-end biomedical engineering department, which includes optics, a huge cell culture and cell biology department. A lot of microfluidics work is being done. Sir himself looks after the sensors department personally. We have an upcoming animal lab, which means an unlimited supply of animal gametes. It has a great advantage, that is, you are not experimenting with human lives. You are experimenting with lower life. We have an ethical committee which has already given clearance for all these things. The automation has come in a big way. We have an AI department. Logistic trainers and HR trainers are readily available. A well-stocked library, which means we are going to have a good interdisciplinary research team and a platform for global networking as far as academic collaboration is concerned. My thanks to Mr. Sandeep Tavte also when he came and joined the entire thought process in terms of equipment and media and disposables too. Together, we definitely envisage a great, a bright, a brilliant future. To end, a great idea which is backed by ethical guidelines and has plenty of, let's say, a basic infrastructure, spiced up with future-looking technology would mean only one thing. It forms the perfect culture system to create a grade 1 embryologist. Thank you. Questions, if at all? Otherwise, I'll be asking the questions in the panel. So.
So will this lab also have an industry interface in the sense that you'll...
Sir, to be very frank, we just started working on it about 1.5 months back. But in the future, we do endeavor to have a better tie-up with the industry so that, we could send people out for, let's say, if I could call it internships or monitored training. Because after animal lab, the next obvious step is going to be handling human gametes too. So after a certain level of competence, of course, we are very sure we will be having an entry exam and an exit exam. A certain competence, like when we recruit a doctor, we first ask him which medical college have you passed out from. So you generally judge a person from his entry criteria into medicine, where he has passed out, where he has done his MD, where he has done his subspecialization from. So similarly, we have decided to have a very stringent criteria because we don't want to tarnish, if I may use the term, the name of this wonderful institute. Yeah, thank you.
Thank you so much, Doctor, for your insightful thoughts and valuable information provided by you. So let's move forward with our keynote lectures by Dr. Lotte B. Straubeck and Paul Hattel, which will be followed by question and answer sessions at the end.
It's my honor to introduce Dr. Lotte B. Straubeck, an accomplished researcher and entrepreneur in the field of assisted reproductive technology. She is the founder, CEO, and CSO of Arts Media Denmark, a pioneering company specializing in IVF culture media. With a doctorate in veterinary medicine and a PhD, she has dedicated her career to improving IVF success rates through high-quality media formulations. Dr. Straubeck has worked extensively in the field, providing consultancy for over 300 animal IVF labs globally and contributing significantly to research in reproductive medicine. She has held esteemed positions in prestigious organizations, including the Danish Society of Reproduction and Fetal Development and the International Embryo Technology Society. Her expertise and dedication have made a remarkable impact in both human and veterinary embryology. Today, she will share her insights on how to choose the best media for better embryo development. So let's give a warm welcome to Dr. Lotte B. Straubeck.
Thank you very much for that warm welcome, and thank you very much for inviting me to speak at your very special occasion. Congratulations with your center, and it's an honor to be for the inauguration ceremony here. You want it closer? Okay. So normally my children tell me that I speak really loud, so I'll try and keep it a little closer. How to choose the best media for better embryo development is a rather large topic. I will try to include what I can within 20 minutes. Hopefully this is the kickoff start for a lot of collaboration between industry, research, and training, which is all three something that I have been very much involved in. The nice introduction, I think, covered about everything I have on this slide, so I will move on quickly. I will honor Dr. Paul Hattel for being my colleague through many years and supporting much of the work I did in University of Copenhagen. A special thanks to Dr. Birte Avery, who was my mentor and still today, as retired, is my daily collaboration partner that I brainstorm with. So I'll move right on to the role of IVF media in embryo development. It's a complex process that requires optimal conditions for success. The culture media we use play a pivotal role in providing successful fertilization and embryo development. Firstly, the media provides essential nutrients, vitamins, and minerals necessary for cell growth, ensuring the gametes and embryos have nutrients foundation required for a healthy start in the lab. It's not really responding. Here it is. Next, maintaining optimal pH and osmolarity is crucial for gamete and embryo viability. This precise control creates an ideal environment fostering the survival and function of these delicate biological entities. Additionally, the IVF media supports cellular functions by facilitating metabolism and development at various developmental stages, ensuring that embryos can progress through critical milestones. Finally, optimizing. Oh, you need to go back. Because I'm using it here. Sorry, I'm almost there. Finally, the media provides essential nutrients, vitamins, and minerals necessary for cell growth, ensuring that the gametes and embryos have the functional start in lab. Now it's working. Finally, by optimizing conditions for sperm egg interaction, our media enhances fertilization rates, promotes efficient embryo formation, and leading to better outcome in assisted reproduction. Together, these components underscore the importance of meticulously crafted media in advancing IVF success. So the changing of landscape of IVF media. In the past, sequential media was tailored to provide different nutrients at each stage of embryo development. In contrast, one-step media has emerged, combining all necessary nutrients into a single formulation for the entire culture period. Thereby, we simplify the IVF process, less handling, and suitable for the time-lapse incubators. And the future AI that we have coming with scoring of embryos. As we look at trends in media composition, we observe an increased complexity with the addition of growth factors designed to enhance embryo viability. However, there is also a growing need for simplification, as overly rich media may overwhelm embryos, and some studies show that diluting media for better balanced nutrient delivery increases embryo development. So we should take on the approach less is more. Furthermore, we are seeing a future direction in IVF that emphasizes moving away from combination of media. This approach suggests that one single formulation, or one basic simple formulation with slight changes for aspiration, fertilization, culture, and transfer. This reduces the stress on the embryos by maintaining a consistent condition. Furthermore, utilizing products from the same media supplier also increases this stability for the embryo's development. Lastly, there is a push towards sustainable packaging within the industry. Many traditional media are stored in plastic. There is a promising trend towards adopting glass bottles, which not only lessen environment impact, but also help maintain integrity. The landscape of IVF media is evolving, driven by the need for efficiency, embryo welfare, and sustainability. Requirements for media manufacturing for IVF media, there are key factors to consider. Some of the essential requirements I listed here, highlighting the most critical factors that ensure quality and reliability. So using glass for IVF media during the production offers also significant advantages. It's inert, preventing leaching of harmful substances, thereby maintaining the integrity of the media. Additionally, glass is easier to sterilize. It maintains the sterility much longer. We can store media in up to 18 months, processed the correct way. An extended shelf life enhances both safety and stability, and it reflects the implementation of robust quality control measures. These quality steps guarantee that every component used in the manufacturing process meets high quality standards and helps determining product shelf life. Obviously, adhering to good manufacturing practices, GMP, is non-negotiable, ensuring that the IVF media complies with industry standards. This includes routine audits, comprehensive quality management system to monitor and uphold quality. By focusing on these requirements, manufacturers can ensure the production of reliability and reliable and effective IVF media, safeguarding the success of assisted reproductive technologies and ultimately supporting positive outcomes for patients. The freshness of media should remain consistent between the newest and older media batches within the shelf life. So the reason I just want to highlight this is that there is a tendency in the industry to require from the manufacturer, I need the latest batch you manufactured. So if the manufacturer is in control of stability testing and the production procedures, this should not be an issue at all. The freshest medium should be as good as the one that has expiration date the same day you want to use it. Stability testing and quality control are important for factors in the media making process. In addition, mouse embryo assays and toxin assessments are performed to ensure the safety and compatibility of the media. Evaluating concentrations of components like growth factors, gentamicin, and human serum albumin should also be included. Visual inspections further reinforce quality assurance, ensuring that all media used meet high standards of efficacy and safety. Overall, these rigorous testing processes are essential in identifying the best media. So the brief history of IVF media in 2 minutes, key points I think is that the first commercial ready-to-use media were in 1988. Midicult, based in Denmark, launched their first commercial ready-to-use, supplemented with HSA. This milestone was crafted by Kjell Bertheussen, established a new benchmark for consistency and reliability in cell culture, moving away from traditional serum-based options. Central to this innovation is the formulation of synthetic serum replacements, which he's patented also in 1988. It incorporates key ingredients such as EDTA, metal ions, elevated insulin levels to enhance cellular metabolism and growth. These components create a controlled and optimal environment crucial for successful cell culture. Furthermore, modern cell culture media have evolved to include a variety of growth factors, which are essential for supporting specific cell types, promoting desired cellular behaviors. Some of these growth factors include EGF, VGF, FGF, IGF, and GM-CSF. In AMIVC, a simplified SSR is included. This refined formulation benefits from extensive optimizations derived from the veterinary media enhancements and animal models. The combination of growth factors and optimized synthetic serum replacements ensures a robust environment that supports a diverse range of cell types and, in particular, embryo development. So I want to just talk also about animal models in quality control in media production, which is obviously also a great model for training. More hands-on, I could not agree more. Quality control is paramount in the production of culture media. So we touched upon rigorous testing, sterility, pH, osmo, nutrient levels. It all ensures we have a consistent product. So veterinary science has stringent protocols in place which can serve as a model for improving quality assurance in human fertility clinics. In some of the species that IVF art is used is in the horses. Cloning is done and ICSI is done. The advantages of cloning is you can create identical copies. There's no downtime during hormone stimulation and pregnancy. We just discussed this over lunch. In the veterinary industry, IVM is 80 to 90%. Cleavage is normally 80%. So there is a lot to be learned to bridge this gap to the human industry on maturation. Other applications in animal for IVF is gene editing. So here you can see a gene-edited BVD, V-resistant calf born less than 1.5 years ago. So the bovine viral diarrhea virus is one of the most important viruses affecting health and well-being of bovine species throughout the world. The first gene-edited calf with resistance to the bovine viral diarrhea virus was produced in 2023. So we have extensive collaboration with zoo and wildlife throughout the world. It gives us a valuable insight in media RD and how thinking out of the box is sometimes necessary. The last photo is a photo of an oocyte from an elephant we were lucky to receive after its death in Copenhagen Zoo. 22 oocytes that we successfully matured and vitrified. And unfortunately, we didn't get any cleavage when we fertilized it with the semen from Berlin Zoo. The last photo is from Thailand when I traveled with my children, now 28 years ago. My daughter and my son now a father himself of 2 children. So some of the titles I'm most proud of is now being able to call myself a grandmother. I have that picture often in my presentations, reminding you, also relating up on your talk. It's stressful to be an embryologist, but it's also awesome. So sometimes we should step back and just have a look of what is it we actually are doing every single day. We are creating life, we are helping people, and then it is also a good reminder that time flies. Time passes by so fast. So it's important to take a break and enjoy what we are doing, and to refine our work-life balance sometimes. That's also a note to self. So I want to touch upon another application for IVF within animals, so bringing back extinct species. So you could ask yourself, what purpose has that? Nonetheless, I should be proud to say that a mammoth was created with one of my media. I encourage you to check out this company, colossal.com, if you're not already familiar with it. They do amazing things. Extinction is a huge problem facing the world. Imagine 50% of the World Animal Foundation, predicts that 50%, that is 1/2 of all our species, could become extinct by only 2050. That's only 25 years from now. The way you do these there is still worked on, so you cannot just take DNA and put in an elephant oocyte, then you have a mammoth. So it's obviously editing genome, implanting it into an egg cell that has related species in order to develop, and then creating several generations of chimeras until you actually have a full-grown mammoth. So probably not in my lifetime. Moving further into animal, I know your center here is based on rodents, which is a great model. It's great for training. It also has some limitations. In media manufacturing, the final control steps are crucial for quality assurance. It's mandatory that we do a mouse embryo assay in order to release our pipetter, our media, anything ART related. It has to go through a MIA test. But assessing performance is equally important, but often overlooked. The mouse embryo assay test primarily detects toxicity, not performance. The MIA lacks the sensitivity to detect efficiency differences in blastocyst rates. With only 20 oocytes and 80 to 90% blastocysts, you cannot detect if there's a difference. The bovine embryo assay utilizes 900 oocytes and provide blastocyst rates in the range of 30 to 50% as a performance measure. The bovine embryo assay test is a comprehensive evaluation that assesses both performance and toxicity, offering a performance indicator. So using the bovine embryo assay as quality control versus the MIA test, the test method used is the same as described for the MIA test in FDA guidance. So there are 3 major differences. The bovine oocytes are also in vitro matured and in vitro fertilized. The embryos are kept in the medium for much longer, as the bovine embryo takes longer to develop. The BIA test uses approximately 200 disseminated oocytes in 2 to 3 replicates, whereas the MIA test requirement is only 20 fertilized mouse oocytes per group and just 1 replicate. So there are huge differences between a mouse and a woman, and there are even more differences between a cow and a woman. The key similarities and testing strategies are that bovine physiology has more similarities with the human model, such as cryotolerance, structure, oocyte diameter, maturation time, and time to reach the 2 cell states, blastocyst and hatching. Therefore, the model can be suitable to investigate in combination with the MIA. The BIA test is therefore an invaluable addition to the MIA test to further investigate performance, safety, effectiveness, and related quality parameters. The comparison of embryo development in human and cow, I have listed the different features that I think I'll not go into details with as time is running out. I can see people in the audience. So it's on our website if you visit artsmediadenmark.com. I'll just touch upon how the BIA test is actually performed. If you're interested in any of these protocols, reach out to HTech IVF or email me. So in addition to the blastocyst rate, we add also kinetics and morphology factors. So this was published by Avery and Greve back in 2004. Are blastocyst rates a reliable indicator of the quality of an IVP system? So adding on the kinetics and morphology, they developed a system where we also look into the kinetics by scoring them in 3 different categories and morphology in 3 different categories. So how it's actually used, I have a practical example here where we test our newly developed culture medium and then a commercial medium 1, a commercial medium 2, and our bovine control medium. It was to my big surprise when I started working in the human industry at Cooper Surgical, purchasing different commercial media and testing them in our bovine system, that there were huge differences in the blastocyst rates. So as you can see, the 39% is very different to the 28%, whereas it's not significantly different in terms of blastocyst from the other groups. These commercial media that I tested, and this one has all passed the mouse embryo assay test, but you do not know in your clinic that if you did a bovine test, it would actually again and again be significantly lower in embryo development. So the bovine embryo assay test is a valuable addition to the mouse embryo assay test. It's not all media. The impact of plastic on embryo development is huge. We did studies showing that if you aliquot media just 1 hour into a cryovial, and we tested several other plastic vials, and then you, following that, do an IVF, you will have significantly lower embryo rates in the group where the media was stored for 1 hour in a plastic vial. So in many clinics, it is routine. It's not what you are taught to be an embryologist. So there's a huge gap between what you are taught when you get to the clinic and what you took with you from your research institution or education institution. When you ask labs, why do we do this? Often they say, but that's what we always did. And when I started here, that's what I was taught to do. This is our SOP. This is our routine. So this is a good way to bring industry and education and the fertility clinics even closer together. I think this center could be a good place to start for this. Now combine aliquoting your media with preparing your dishes with these plastic pipetters. We did that experiment as well. So dishes prepared, media and oil with a Pasteur plastic pipetter, significantly lowers development rate compared to when you use a pipetter mouse embryo assay tested with filtered tips. So now combine the two and you are off to a really poor start for those patients. Again, choosing a better medium. The best medium is only as good as the pH from your incubator setting. And your incubator setting defines the pH by monitoring the CO2. Monitor the CO2 carefully every single day. So if you increase CO2, you will decrease pH and vice versa. But if you know what concentration of bicarbonates in your media and you are in full control of the CO2 of your incubator, you have a very accurate knowledge of your pH. I know it's very popular to measure pH, and again, this is the most reliable way you can ensure you have the correct pH. So, know your incubator gas temperature and altitude rather than measuring pH. Research-backed media. There's a significant collaboration from us in Denmark with university hospitals in Copenhagen that were originally pioneers within the cryopreservation of ovarian tissue. We are working currently on a new maturation medium. The overall message is industry should work closely together with universities, with the fertility clinics. It allows us to contribute to cutting-edge research, but also ensures that we receive valuable feedback from the researchers and the clinicians that we work together with. Such a collaboration is essential for continuously enhancing the formulation and effectiveness of our media and in supporting the embryo development. And these advancements in media development benefit both from veterinary and human medicine. So the role of scientists as media manufacturers, I think I touched upon that already. It's important to be in collaboration and network and bridge the gaps that seems to be between the industry, the education, and the media manufacturers. So to summary, key highlights: how to choose the best media. One-step media, it simplifies the IVF process, it reduces handling stress on the embryos, and it's very suitable for the time-lapse incubators, and who knows what else AI will offer in the future. Complexity versus simplification, less is more. So overly rich media may overwhelm embryos, and diluting media can improve balanced nutrient delivery. The future-focused trends towards single formulations for all stages: aspiration, fertilization, culture, and transfer. It reduces stress and ensures consistent conditions for the embryos. Then there's supplier consistency. Using products from the same supplier enhances compatibility and stability. You will have a basic formulation that's based on the same, and you have less stress in terms of pH, osmolarity. And then scientific development, make sure to be close in development with scientists, buy media from scientists that are developed by scientists. And sustainability initiatives, movement towards glass rather than plastic is a strong encouragement. So I look forward to, I look forward to exploring how we can align and implement science and industry strategies together. Congratulations again on your new center, and thank you for your attention, and thank you for inviting me. I think there are questions later, right? I can take questions now also if you want. Any questions, or you want to keep it for the panel?
It was a very informative lecture, ma'am. We learned a lot. So, our next esteemed speaker is Professor Paul Hettel, a distinguished scientist in reproductive biology and embryology. Holding a DVM, PhD, and DSc, Professor Hettel has spent decades advancing research in assisted reproductive technologies. As a professor of anatomy at the University of Copenhagen, he has made groundbreaking contributions to the study of oocyte maturation, early embryonic development, and stem cell research. Professor Hettel is internationally recognized for his pioneering work on bovine models of fertilization, which have played a crucial role in understanding human reproductive medicine. His research has led to a significant advancements in art, benefiting both clinical and laboratory applications. Today, he will be presenting on oocyte development and fertilization, a bovine model. Please join me in welcoming Professor Paul Hettel.
First of all, I'd like to thank you all for coming and thank you for the invitation to give this lecture at this very prestigious day today. I'm going to talk about electron microscopy of oocyte development and fertilization and use cattle, bovine as a model. So, should I use the, I can use this. So both Lotte and I, we come from Denmark. You can see Denmark up here, located in the cold north. Now we are in a much better environment here in India. I've been professor of anatomy for more than 40 years. And on the next slide, you see the anatomy building at University of Copenhagen at Frederiksberg in middle of Copenhagen. In the end of the building over here, I've had my old electron microscope standing. This is about 25 years old, this microscope, but that is a microscope where most of the images that I'll be showing you today, they have been taken. So why talk about bovine in vitro fertilization at a meeting like this, dealing with human IVF? Because bovine, as Lotte also referred to, that's a faithful model of human IVF. Bovine is a mono-ovulatory species, and the time span of oocyte development is very similar to human. Also, the bovine embryo assay, as Lotte described, that is a more sensitive assay for human IVF media than the mouse embryo assay. Let's have a focus on bovine versus human IVF. Up here you see the human IVF process line with the retrieval of the mature oocyte at the metaphase of the second meiotic division, sperm preparation, in vitro fertilization, culture, potential vitrification, embryo transfer. In cattle, bovine IVF is a bit different because in cattle, the oocyte is retrieved at the immature stage. So this is the prophase of the first meiotic division. Subsequently, it is processed for in vitro maturation for 24 hours, and then the following steps are similar to what's used in human. So the big difference, that's the in vitro maturation, which is a complete standard process when doing bovine in vitro fertilization. During this presentation, I'm going to focus on different aspects. I would like to describe certain aspects of oocyte growth in the ovary. Then we'll reach oocyte maturation, which occurs in the tertiary follicle, the antral follicle, just before ovulation. Then I'm going to touch upon fertilization. And at the end of the presentation, I'd like to comment on some relations between oocyte competence and oocyte growth. I'll only, in this short presentation, be able to give you some small windows into the morphology and ultrastructure of the oocyte and embryos. If we just turn to the next slide, you see again, this is our old transmission electron microscope. So we've been using both scanning and transmission electron microscopy to visualize oocyte maturation and fertilization. We are working at magnifications up to 100,000 times. And if you try to imagine what that would mean for a bovine oocyte, then here we have a bovine oocyte during fertilization. It's about 140 micrometer in outside zona pellucida diameter. And if you imagine that being magnified 100,000 times, it will correspond to that the oocyte would be 14 meter in diameter. So that gives you an idea about the degree of detail we can study with this technology. So in order to make the presentation a bit more easy to follow, Then I've made a pseudo-coloring of the black and white images that we get from the transmission and scanning electromicrograph. They are only, the electron beam only has one wavelength, so these images, they are black and white images that can be pseudo-colored for educational purposes. Let's have a look at the first process, the oocyte growth, that occurs in the ovary during follicular development up here. So the important missions of oocyte growth, that is to increase the oocyte diameter, the oocyte size, from about 30 to 120 micrometer in diameter inside zona pellucida diameter. Then also it is to furnish the oocyte with all the essential organelles and molecules that are required for initial embryonic development. We should remember that it's not until in cattle and human also, until the 8-cell stage, that the embryo becomes fully transcriptional active. Then the mission is also to acquire the competence for final maturation and embryonic development, and I'll specifically focus on this final maturation and the competence for that at the end of this presentation. So we start off with the primordial follicle, and this is the pool of resting follicles in which the oocytes are also arrested in the prophase of the first meiotic division. From this pool of follicles, there's a continuous recruitment of follicles that will move on, grow to the primary follicular stage. And later on, they'll continue their growth to the secondary follicle. And that's why we will take the first small window and look into the oocyte ultrastructure, because the secondary follicle is a very important time point for oocyte development. This is a light micrograph of the secondary follicle. You can see the multi-layered, 2 or 3-layered granulosa cell layer here. This is the oocyte, and this is the oocyte, the germinal vesicle, at the prophase of the first meiotic division. You can see that there are mitochondria scattered all around the oocyte cytoplasm, and if we look into a small detail of the oocyte out here in the interface between the granulosa cells and the oocyte by electron microscopy, then you will see that we have the granulosa cells in green here, we have the orange oocyte here, and you can see that there's an intimate contact building up between the granulosa cells and the oocyte. And where this intimate contact is seen, we have the formation of gap junctions, allowing the granulosa cells to somehow transfer important molecules, RNA and proteins, potentially into the oocyte for furnishing it with the competence and abilities to develop and fertilize. You can also see that between the granulosa cells and the oocyte, there are patches of zona pellucida substance building up now. So this is where the zona pellucida is produced in this secondary follicle. Then we continue development, move on to the tertiary follicle, the antral follicle. The oocyte will increase in diameter. And if we look at a tertiary follicle by light microscopy, you can see here the multi-layered granulosa cells, the antrum is forming, and we have the oocyte located here now, totally surrounded by the zona pellucida. And if we look into an oocyte of a fully grown tertiary follicle, this is how it looks. So we have the complete zona pellucida, the cytoplasm here, and the prophase 1 nucleus here. And you can see that the cumulus cells, they have long projections that penetrate the zona pellucida. We'll come back to that in just one moment from now. In this fully grown immature oocyte at the prophase of the first meiotic division, let's have a look at the electron microscopy to see the organelles. And you can see here now that all the red stuff, that's the soda-colored mitochondria. So the mitochondria, they've now moved to the periphery of the oocyte, just underneath the zona pellucida and the granulosa cells up here. You can see that the mitochondria, they are closely associated with green, smooth endoplasmic reticulum here. And also you find that there are big clusters of these blue granules here. They are the cortical granules that we'll need for protection against polyspermic fertilization. You'll see that in just a moment from now. So if we look into the oocyte over there, and just have a look at the interface between the granulosa cells out here and the oocyte, then we have these very, very long projections that penetrate the zona pellucida and establish these gap junctions to the oocyte. So there's still in the immature oocyte, just up to the time of final oocyte maturation, there's a continuous communication from the granulosa cell to the oocyte and vice versa. So the oocyte is established with its competence. Then we'll move into oocyte maturation. In vivo, the oocyte maturation is triggered by the LH surge from the pituitary gland, but it can also be performed in vitro just by isolating the cumulus oocyte complex from the tertiary follicle. The important missions of the oocyte maturation, which is only a 24-hour period in cattle. It varies from animal species to animal species, but in cattle it's about 24 hours. One important mission, that is the resumption of meiosis and the extrusion of half of the homologous chromosomes in the first polar body. The next I've chosen to focus on, that is the establishment of the block against polyspermic fertilization. And that's what we're going to visualize now in the microscopical images. So here we have the immature oocyte at the prophase of the first meiotic division, and about 10 hours into maturation, the oocyte looks like this. The germinal vesicle, or the oocyte nucleus, is now breaking down. You can see the nuclear envelope is somehow undulating, and the chromosomes in the nucleus, they are condensing. Now, if we look into a small detail of the oocyte up here, then a very important action has occurred, namely that here we have the zona pellucida, the periveteline space, and the oocyte. And you can see that these long cumulus cell projections, they have now retracted from the oocyte. The oocyte is isolated, and that is presumably what triggers oocyte maturation and resumption of meiosis. About 15 hours into maturation, we've reached the metaphase of the first meiotic division, and you can see that the cumulus cells, they have now expanded, and that process continues up till about 20 hours after maturation, when we have the telophase of the first meiotic division, with the homologous to be extruded in the first polar body here, and those to be retained in the oocyte here. This is the mid-body you're seeing here. That's where the polar body will be broken off. And about 24 hours into maturation, we have the metaphase of the second meiotic division, the first polar body formed. I talked about this block against polyspermic fertilization. And that's what we can see if we look into a detail of the oocyte here around the first polar body by electron microscopy. And here you see the first polar body in the periveteline space, the zona pellucida out here. And here we have the oocyte. And now you can see that these blue cortical granules, they have now lined up in a long row just beneath the oocyte surface, just under the oocyte plasma membrane, in order to be completely ready for establishing the block against polyspermic fertilization. Let's have a look at what then happens during fertilization. So now we move into the oviduct, and the coming images I'll present to you, they are from in vivo fertilization in the oviduct in the cow, except for this one, which is taken 1 hour after in vitro insemination. This is a scanning electron micrograph of a cow oocyte 1 hour after insemination. And you can see the granulosa cells surrounding the oocyte, but also big, huge areas of the zona pellucida is actually naked, and the sperm, they are attaching to this part of the zona pellucida. At this time point, the spermatozoa, they are undergoing the acrosome reaction in order to penetrate the zona pellucida. And if we look into the oocyte, or now the zygote because it's fertilized, 2 hours after ovulation, we already at that time point, we find the sperm head with the sperm nucleus inside the zygote. This is the surface of the zygote, and you can see that the membrane coverings, the nuclear envelope of the sperm head is now dissolving. If we look at another detail of the same oocyte, the same zygote, you will see that on the surface of this zygote, all these blue cortical granules, they are now liberating their content by exocytosis. These are proteases that will react with the zona pellucida and establish the block against polyspermic fertilization. So this is a visual impression of this block against polyspermic fertilization. This was a couple of hours after ovulation, and if we move on to another hour ahead, we get to the point 3 hours after ovulation, and at that time point you can see that the full spermatozoon has now been taken up into the cytoplasm of the zygote. The sperm head is located here, the sperm tail extends to this direction. And if we try to look at this by electron microscopy to see the details of the sperm head, this is the surface of the zygote, and you can see the sperm head over here. The sperm midpiece is extending out here. Here, the sperm tail starts by undulating, so it goes in and out of this ultra-thin section of the zygote. The sperm head is decondensing now, and you can see that from these mitochondria here, smooth endoplasmic reticulum, the green stuff, is moving towards the sperm head to create nuclear envelope around the sperm head. That is the formation of the paternal or male pronucleus. So let's have a look at this portion of the zygote. We have the sperm head, and you can see how this smooth endoplasmic reticulum starts to form the nuclear envelope, first on this side of the sperm head, but secondly on this side afterwards. So the sperm head will be completely covered by a nuclear envelope. This is about 3 hours after ovulation, and in the coming hours, up till 6 hours after ovulation, we have somehow a swelling of the two pronuclei to this typical spherical appearance of the male or paternal pronucleus and the female or maternal pronucleus. Over the coming hours, up to about 18 hours after ovulation, the two pronuclei, they migrate to a close apposition here in the zygote. And during that migration, they complete the DNA synthetic phase, which allows them to duplicate the embryonic genome and allows for the division or the cleavage to the 2-cell stage. So we go the other way around to the 2-cell stage here. So now we are about 24 hours after ovulation, and we have the 2-cell stage formed. And each of the cells, they have this full copy of the unique embryonic genome. Then finally, I mentioned that I'd like to give a few comments on the relationship between oocyte growth and oocyte competence. And what we did was to harvest immature oocytes by slicing of ovaries, so we got oocytes that came from smaller and larger follicles. And when looking at these oocytes, we could see that some of the oocytes, they had a smaller inside zona pellucida diameter, less than 100 micrometer. Some of them, they were in a middle category of 100 to 110 micrometer inside zona pellucida diameter, and some of them, they were larger at 110 micrometer in diameter. And we when we submitted these oocytes, these 3 size categories of oocytes to in vitro maturation, it turned out that the oocytes that were less than 100, they were unable to resume meiosis, they were unable to reach metaphase 1, whereas those oocytes in the mid group here, they were able to resume meiosis and meet metaphase 1, but then they blocked and were unable to progress to metaphase 2. Whereas those from the larger size category, they were able to both resume meiosis, reach metaphase 1, and then continue on to metaphase 2. Then we tried to examine whether there would be any subcellular background for these different competencies. And when we looked at that, we looked at the oocyte transcriptional activity by means of treated uridine incorporation and autoradiography on sections of the oocytes. And what we found was that there was a heavy labeling with these autoradiographic grains, that's the dark grains seen over the oocyte nucleus here, indicating that there was a very active transcription in the small size category. In the mid category, you can see that the labeling has decreased a lot, so the transcriptional activity is decreasing, and in this larger size category, transcription has completely ceased. And that is somehow an expression of that the smaller oocytes, they're still building RNAs and proteins that are required for their competence to undergo final maturation. These oocytes, they have built most of the RNA and proteins that are required for their competence, whereas these oocytes that are larger than 110 and fully grown, they have produced all the RNAs and proteins that are required for their final maturation. So that brings us to the end of this presentation. So I've made a few conclusions here, that the full process of bovine oocyte growth and maturation, as well as fertilization and embryonic development, has been detailed by electron microscopy, telling us lots of things about the subcellular mechanisms of oocyte development and embryonic development. Bovine in vitro oocyte maturation, IVM, has a high success rate with about 90% reaching metaphase 2, 80 to 90% reaching metaphase 2, if the oocytes are harvested at the fully grown size category, which will correspond to a follicular size of about 3 millimeter, I can say. Also, we found that the bovine oocyte achieves competence for reaching metaphase 1 at a diameter of about 100 micrometer, and the competence for reaching metaphase 2 at a diameter of about 110 micrometer in diameter. So with that, I would like to end my presentation by thanking you very much for your attention, and then wishing warm luck with this inauguration and the subsequent activities. Thank you very much.
Thank you, sir, for your informative lecture. So now we have moved forward with the question and answer session. So if anybody have any questions, so please move forward. And also people who have joined through online, please raise your hands in order to ask questions so that we can unmute you and answer your questions.
So, we now come to one of the most engaging and insightful segment, the panel discussion. This session aims to address some of the most critical challenges in the field of clinical embryology, focusing on the gaps in training, skill development, and competency assessment.
This discussion will bring together experts with diverse perspectives to shed light on how we can enhance training programs, improve skill acquisitions, and standardize competency assessment to build a stronger workforce in IVF sector.
We are honored to have an esteemed panel of experts joining us today.
Thanks. Self and Sanket will be doing the honors of asking the questions. There is no specific people that we are going to direct the questions to. Okay, Akash has come. Okay, so Akash has joined. I'll be directing a few questions at Akash, Vijay sir, Varsha of course, Paul and Lotte of course you will be targeting. We will be targeting you rather. And where's Rohit? Dr. Rohit is. Okay, he's around. And Shilpa and Vivek. We'll be sending some questions on to you too.
So you can start.
You start. PPT. Just a sec. The PPT is being loaded, I guess. Skill development and competency in clinical embryology. And it's not going to be, the questions are for mutual understanding and mutual improvement, so it's going to be directed to all. So anyone who's surfing the mobile or yawning, please be careful. The questions might just fall your way. Okay. The first thing is that are we allowing our trainees to do things, or are we allowing them only to watch? Anyway, it doesn't matter. Are we they enter the place instead of actually doing things? Are they just watching things? Varsha, you have been in training for quite some time. So where do you draw that line, and when do you allow a person from theory to practical?
So practically, when we receive trainees, what is the level of competence that they come in with? And this is very much to do with what kind of training has been given to them, right? Now, if you look at the present scenario where all of them are supposed to be doing 4 semesters of masters in clinical embryology, and they come to where they are placed in the hospitals, they are exposed to multiple departments. But how is the training for the embryologists done, right? Do they have that kind of an exposure? No. So when they... Is it my mic or is it yours? Of competence as far as skills are concerned are very low, are very poor, right? So 1 year we place them as trainees, and what is it that they do in this 1 year? So we have a structured program where we allow them to observe certain number of procedures, then following that they do the procedures under supervision. This is for 1 year. So are they independently performing any procedures? No. But are they just watching or observing? No. Part of the process is observation, and part of the process is performing procedures under the supervision of a senior. And this, I think, I would say it's majorly because of the gaps that come from the training sector. Yes, so if the question is directed towards how do you do the competency mapping, how is the learning curve, we all know that it varies from person to person. If we look at what is available in the literature, we would say, okay, 40 to 50. For example, vitrifications they would have done under supervision, and then they are, capable of independently handling it. I really wouldn't go by that formula at all, just knowing that everybody has a different learning curve. Ideally, what is it? Statistically, there is a proven model which is called as learning curve of cumulative summation, right? So you kind of graph, you set a goal for them. For example, if it is vitrification, the goal is that whether the embryos are surviving post-warming, right? So, but in practice, are we doing this? No. This is more of theory. So ideally, for example, for vitrification, once the candidate has done around 45 to 50 vitrifications, then we take them up for competency mapping by a senior. We have set goals of mapping, and if they've cleared those goals, whether it is survival, whether it is fertilization after ICSI, if it's the oocyte. So once they've cleared that competency level, then we say yes. The duration may vary, different procedures, the learning curve is different, duration of exposure is different. So is there a set rule? No. So it is the senior who decides. Now they've done so many under supervision and they are up for competency evaluation, which is done. So the competency evaluation is never done by the trainer. It is always done by somebody else who's not been a part of the training process of the trainee.
So there is a subjective assessment and an objective assessment. There's an internal assessment and an external assessment. That is what
Yes. In an ideal world, it shouldn't be subjective, but unfortunately, this is how it is done in practice unless we go for the statistical method of learning curve cumulative summation. Only then will it be it will not be subjective. So to eliminate that subjective bias, you need to get a third person to evaluate the person who's been trained. That's the best that can be done in a practical scenario. This is only for the procedures, if I may say.
Rohit, I'll address the next question to you. How would you assess when is a gynecologist competent to independently perform a certain procedure when it comes to IVF? Because a small mistake on the gynae side or on the embryology side actually leads to disaster, especially in such a niche specialty.
Very interesting question, actually. See, I personally feel that embryology is an evolving science even today, and most of the runners of this science were basically technicians, and not to use it in a bad way, in a not so uncharitable way, who learned on the job, and therefore the first primary skill that what to be imparted to the student was the hand skill. So that was what is as far as embryology is concerned. Same thing applied to us also maybe 150 years back. So people like surgeons had assistants and they learned the hand skills first. But luckily what has happened is there's wealth of literature and academics that's been created. People have to go through that process. The internship that you mentioned, that is a very kind of rigor exercise that you go through and you acquire the basic skills, the personal hygiene, the surgical sterility, sense of surgical sterility and those things. So that makes you a good candidate to start learning with you. Now coming for us, as far as the training of the clinician is concerned, it's a lot more standardized, to be very honest. You go through the shadowing, the rounds, the patient histories, and you ask questions in an academic, in a theoretical setting. And once we get the answers from them, they can train on simulators also. And therefore, they have enough time and opportunity to actually get onto the patients directly. Somehow, yes, you're still around when they're doing the stuff initially. So there is a hand-holding that happens for 4-6 months. And I would say that's a good standard way of training your next generation of clinicians as far as. Embryology, what has happened is, it's been like a high complex lab that's become very quickly, very soon. So even the senior guys in that business are not really knowing how to impart that training in a holistic way to the new guys.
First, a very good afternoon to everyone, and thanks to Professor Renu George, Dr. Sandeep sir, and Sanket for inviting me over here. And sir, if I can just go back to your previous question, where you had said, why are the trainees still watching and not doing? That would form the part of the answer over here. So the reason is we don't have a level playing field. We don't have as such set rules who is to be considered a qualified embryologist. They have given this many number of cases or procedures, even according to the new law, they have just defined this many number of procedures to be done. But what is the... previous. Yeah, even for this, they have given 2 years. 2 years of experience post-MSc. 2 years post-MSc. Sorry, I'm saying for MBBS, it's 2 years, 3 years, and 1 year for different categories. It is different post-MSc. What they have done at the basics level based on that. So they have defined only in terms of time, not in terms of skills. So that is one reason major, because it's like more like, I may say, it's like government where it's your number of years into the profession decides how you get promoted rather than your skills. So that is one area. Next, the level of knowledge in terms of being industry ready, what is being done over here. So I think that is one area where we are properly lacking. What the industry requires is more of a hand skill, as said by Dr. Rohit earlier, because it's more of a hand skill. Embryology is, when you go into the lab, it's probably 70-80% hand-eye coordination skills, and 20% of your theory helps you, the 80-20 formula. So there, we don't have properly set up infrastructure which trains all the embryologists which are industry ready as such, as of now. So once we have that gap, they are infrastructure set up, but they need to be industry ready. They need to be competent enough to do those procedures. And once, like said, in the last couple of decades, the industry has seen a very rapid change. What we have seen, the evolution of the instruments, technologies as such. Say, you have seen a major technology come every decade and a half, roughly. You had IVF first, then you had your ICSI coming in, then there was vitrification and warming which came in for a decade and a half. So it's evolving very rapidly. So there's no bar minimum. We had luckily one paper, Vienna Consensus, which said about what should be a competency level. But then, it's always very challenging to give that first case. There's no turning back. And in terms of getting the simulators, probably what comes into play is the cost of equipment right now. So if you don't have that simulators to work on, then it becomes really challenging. How do you assess the person in a real world situation? And you are having only maybe beads at best, or somebody who are lucky enough animal lab to have those embryos. So each embryologist has a different way of doing a certain procedure. So there's no equal, or what we may say, a standardization over here. So what do? Then each one gets to train their own way. So that gap needs to be bridged. I think that is one area which needs to be bridged according to me. And unless that happens, it's going to get difficult more down the line. Sorry for the more elaborate part.
Yeah, Rohit sir, please.
I think it used to be what he said, Akash, is that it used to be the how to do it, but now we are moving towards why to do it also. So embryology, I think even today, is unfortunately all hand skill, and it has to move from hand skill to more theory and more academics.
Yeah, that's exactly what I wanted to emphasize in my talk too. It's just not a skill that we need to acquire. It has to be skill backed by knowledge that needs to be actually passed on to the next generation.
Does, critical thinking,
as a team player,
counseling patients. So every aspect of their responsibility should have a proper
match.
Competency mapping. And I think in today's scenario, each organization, we sit together, we brainstorm, and we have our own ways of devising a standard protocol. How are we going to do the competency mapping based on the numbers, the cases handled, our workforce, so on and so forth.
Yeah, thanks Varsha for that. So, let's move on to the industry side. Shilpa, this is for you. So, is just skills adequate to get a promotion in Merck? No, and what are the things that you would actually look for?
So first and foremost, thank you so much for inviting even us, the industry side, to this forum, and congratulations to the whole team for ideating and getting this particular faculty into IIT Hyderabad. From the skills perspective, of course, core competencies, like in any field, are always important. But as you move up and as you grow yourself as a professional, of course, it's the holistic development that you've had, right? It's always about the overall competency that you have beyond your core competency that matters. And that is where, in any industry, anybody would grow up the ladder, and the same is true for Merck. So I believe connecting it back to the topic on what we are, I think as Roy ma'am has also pointed out, as Dr. Gudgutia has also pointed out, it is not only about the skills, it's about how the embryologist gets integrated with the overall stakeholders who are there, who are important in taking a decision about that particular IVF cycle. How that person's decision-making ability, that person's confidence in guiding the key IVF specialist in what is the right way to go about the protocol is also something which really matters. And for that, a holistic level of education really matters, and understanding really matters.
So I'll take the next question to Sudipto. Sudipto, I mean, you understand that, I mean, for me, just being a doctor is not adequate. For Sanket, possibly, just being an embryologist is not adequate. So how important do you think is associate skill development, let's say management, or let's say financial management, or logistic management, important in the basic degree course? I mean, possibly should MSc embryology per se, I mean, hoping that MSc is the basic degree, or MBBS for a doctor. How important is all these courses to be, I mean, all these facets of the modern, if I may use corporate medicine, how important is it, and how would you want to possibly, what are your thought process, how to permeate the system?
Absolutely. No, thank you, sir. And thank you for the opportunity again, and thank you for inviting us. So I think, yeah, today I guess lot of discussions on the whole set of, I guess, the academic part of it, and of course, how it can lead to betterment of patients. But I think this is also important from the long-term perspective, from the pharmaceutical point of view, especially when we look at improving and personalizing patient care and taking it to the last mile benefit. Now, one thing is, of course, when we look at corporatization or maybe pharmaceutical, it's either possibly more on the drug side or possibly more on the technology side. But I think at the end of the day, probably it's more of a multifactorial environment, or we can say an ecosystem where every aspect has a critical role to play. Now, if we possibly for a moment think aside that maybe pharmaceutical is not just about business. Pharmaceutical is probably also adding to the benefit, trying to get resources that can actually connect and help to improve academia further. Because academic is one thing, what you said rightly, it's probably something which is more in a more controlled environment, a more protected environment. But at the same time, I think when pharmaceutical company actually comes into play or probably helps to build those networks across, this is where possibly you also get to know what is really happening on the other side. What is really the industry actually evolving into? At the same time, I think working with the networks of pharmaceutical companies, it also enables you to connect with overseas centers of excellence. That actually helps you to kind of, get those international experiences or international experts into your clinic, into your academia to help your own fraternity further improve. So I think ultimately collaboration is one thing. Second thing is probably, working towards building better centers of excellence. And third, I think, of course, ultimately keeping patient benefit at the, as the end goal, which probably drives both of us.
Yeah. Thanks for that, Sudipto. I mean, it reminds me of a very old tagline from Tata, we also make steel. So we should be also possibly saying that we also make babies. I'll hand over to my co-moderator.
Yes, sir. So this question is for Vijay, sir. I think you have seen embryology from past 2.5 decades, right? So how have you seen, sir, like what is the current landscape of training, especially in embryology, in the country as well as outside? Because for clinicians, there are stimulators, a lot of competency marks are there, but for us, it is nothing.
Well, the training of the embryologist has many different aspects, An embryologist should be someone like, he should have knowledge about many, many different aspects not only of the embryology, but some part of the clinics also. Because when he sees the follicular fluid coming there, you know, by looking at the follicular fluid, he should be able to tell the clinician, you know, at some point of time, that whether you have done one day early or one day late, or we are going right. There are cells, there are different kinds of indications. He should be able to tell the clinician while doing the pickup itself that, oh, I got the endometrial chocolate cyst coming up here, so please avoid that or wash the needle again. These are the types of the feedback that he should be able to give. Unless and until he has seen it, he won't be able to do it. The same thing is true with, you know, different kind of maturities. When an embryologist is taught that, okay, this is how an egg looks like, when he is trained only on the mouse or only on the bovine, it is practically not possible for the person who is training him to teach him that how an completely over matured egg looks like. Unless and until he will start doing it, you know the cases, then only it will be possible. So there has to be some means to teach him all these things. Similarly, the documentation is an extremely important thing in documentation, particularly now when the ART bill has come. So these all aspects should be incorporated when we say that we are training an embryologist. So absolutely true that, you know, the how to know and when to do it, that is a totally different thing. It is important, no doubt it is important, it has its own importance. But why to do is at each point of time, he should be told that this is why he is doing it, he should know why he is doing it. Why he is picking up the petri dish in a particular manner, why he is doing the droplets in a particular manner, why he is making particular size droplets, you know, all these things he should be able to know, and then he will be able to improve the outcome ultimately. So we are lacking in that aspect somehow, that we are doing in the basic training, that okay, this is how it is done, this is how the ICSI has to be done, this is how the needles are to be put, that's all. The troubleshooting which is equally important, you know, he should be a little bit engineer in himself. Because at the 11th hour, if your monitor is not working properly, if the injector is not working properly, then how you will overcome? You are not going to tell the patient that, sorry, I cannot do your ICSI because my machine has failed. This situation should not arrive. The center may or may not keep a backup. It depends upon the center. Ideally there has to be. But suppose somewhere at some point of time it gets blocked. While doing the home pickup, suppose in the stereo microscope, the bulb is not working properly. So what you are going to do? These are the technical, the practical things that we have faced. We have overcome this. But these are the things that are taught to the embryologist. This is what I think, and this is what we are lacking. The basic curriculum and course involves only the theoretical aspects of it. Practical things should be more to be added to that.
Yes, sir. That's well said, sir, because we have to move from the passive learning to hands-on learning. It's a high time for now. And Dr. Lote, what is your take on this? Like, you've been working on the bovine model for most of the years, right? So how different it is from the human embryos? And especially when it comes to training, how does the veterinary people get trained?
So is the microphone on? Yeah, thank you for a good question. I was about to jump in. So the biggest difference is that the cows or buffaloes or sheep and goat, they don't do too well with ICSI. So that particular part is difficult to train. But I really liked what was said about the holistic approach and being a troubleshooter with all the different details. I think at a training center like this, it could be fantastic to engage with a slaughterhouse of small ruminant sheep or goat or buffaloes, because one thing is the skill and all from the textbook and all you're told. Another thing is a more soft skill, like the feel for it. It's not it's a talent. Either you're passionate and you understand it, and you might as well learn that before you get to the lab, whether you at all like to do embryos. We had a very talented PhD student. She had top grades in everything. She needed some results in bovine embryos for her PhD. However, whenever she came into the lab, she did everything right, but she hated the lab work. She loved the paperwork. So whenever she was in the lab, we had infection or we had serious development or everything went wrong every time, and it was very clear that she was never going to be an embryologist. But we couldn't say what she was doing wrong. So you need to like it. You need to feel passionate about it. And I think for the training, it's good consequence to see when you, I mean, even if the slaughterhooses are far from here, you can mature in HEPA's buffered media on the way. You have 24 hours to drive. When you sit and you see the mature oocytes, you see, you develop the feel already then. Does it have many or few cumulus cells? That already tells you the quality of the oocytes. They are different in the way you don't see pronuclei because they contain more lipid, but you still develop the feel for what is the consequence after a successful fertilization, and to follow the embryo development. You can see, you know, if you can over mature them, you can play with them because you don't need the embryos, and you're allowed to make mistakes. It takes some of the pressure off you as well. So I think it would be a fantastic supplement to the rodents. You have to have that training add-on. So I would definitely add that as well. But there are differences. But you can train ICSI on a mouse. You can do it on a cow oocyte as well, or a buffalo oocyte, but you'll just not get a whole lot of development.
I think the only thing that cannot be taught in a lab is possibly empathy. I mean, that actually, I mean, it requires a lot of maturity from the senior person to pass on to a junior person. I mean, empathy at all levels. In fact, when we actually convey the negative result to a person, also it requires a lot of passion when we actually speak. Sir, you would have faced a lot of these situations. How would you teach empathy to one of your students?
So even the new MBBS curriculum now has ATCOM in it. And I think that's a wonderful addition that they've done to this new curriculum. So attitude is what personally, I'm not very comfortable with the word empathy. I would rather call it attitude, because I personally feel that while being empathetic, you become sympathetic, and that's not always welcome to the client. So in my clinic, at least, we have a very clear client service approach, and we want to keep it that way and not really treat you, because the moment you try to treat somebody, you become God. So we don't do that. So in my clinic, what we do is, first, the good news. Whoever gets pregnant, and it's an IUI carried out by a new joinee, that person gets to meet the client. So that joy of being involved in somebody's pregnancy is kind of inculcated into the system. And then, of course, the negative meetings, we call them review meetings. We schedule it around 7-8 days after the negative beta HCG. So usually the clinician and the embryologist are both together. The embryologist is allowed to bring her understudy along with her, and they are all present. Even my, let's say, colleague is also present, so 4 or 5 people are there in the room. And we've been doing it consistently for the last, 15 years now. So that's when you start talking, and then there's some times where the client comes and meets the lab first and then comes and meets us. So they're talking to the client directly. So this is how we do it.
Yeah, well, moving on, mastery in any subject with respect to embryology also, it is like time spent in the lab, right? It's just time spent, or the deliberate practice or hands-on experience is what matters, right? So does this rule apply for embryologist also, the 10,000 hour rule, or there is any different path apart from this? Akash, would you like to take this?
I was not aware of this rule till now, actually. So 10,000 hour rule. So, I mean, it's for embryology, yeah. So 5 years as pertaining to embryology, I think this is the line where we say that at 5 years you become a senior embryologist. It's a convention type, what we put it, it's, if I may say. So probably by 5 years, if you're working in a clinic with a good enough volume of cases, you could get exposed to maximum number of variety of cases. So probably that's what we are looking at. You had been in situations where you don't know what to do.
Is that just time or the number of cases also?
No, I think it's more to do with competency, and the number of cases is what I always firmly believe. What use is if you are 10 years or not 10,000 but 20,000 hours into it and still your competencies are lacking. what you were earlier saying, you're not so holistic in your approach. So I think it's always more than time, it's the skills and competency which matters. 10,000 hours, maybe not. It's something to do more with the number of cases. I would say someone who has done around a couple of hundred of cases of each variety, that would give them quite a good exposure for this.
Thanks, Akash. I mean, actually, what you said about skill and knowledge is absolutely correct. I mean, it's a thing which goes hand in hand. But what is also important, I feel, is what Dr. Rohit said. It is called, I think the book was Count Your Chickens Before They Hatch, Arindam Chaudhary. The ASK principle is what he talks about, attitude, skill, and knowledge, and in that order. So the first thing possibly is, most important thing is attitude. If you have the correct attitude, the skills will automatically come in. And with skills, and if you have the attitude and skill, the knowledge will automatically flow in. That's what he talks about.
Yes, sir. So whenever I was into the position for hiring people, the number one order would be attitude, like what you have said exactly. Because attitude can never be taught. It is something what you always have, or you have inculcated yourself. It can never be taught. You can, if someone is lagging behind, you can pull up in them up in terms of skills. They can put in their efforts for skills and knowledge. But that attitude, owning up the things, taking up the responsibility, maybe going that extra mile for what your responsibility is, that can, I think that can never be taught. That is something which a person should have.
Willingness to learn.
Willingness to learn in terms of attitude.
And I don't know, this is just food for thought. No, I think most of the embryologists, when we begin our careers, we are used to looking at cells, embryos as cells, right? We do not see the couple behind that cell, right? We do not understand the consequences of what we do could impact a family in a very harsh way. And one way of also training an embryologist to be more responsible is also to involve them as counselors. And as they grow up the ladder, they should also be involved in doing the embryology counselor. Who better than an embryologist to talk to the couple about total FERT failure or an embryo arrest, right? This works both ways. One, the patients also know that the person who performed it knows what he's done, and has enough scientific reason behind it. Second, the performer also knows that he is answerable, and you know that that essence of empathy will seep in, responsibility will seep in, that they are responsible equally towards the patient. When we say it's a team effort, usually it is left to the clinicians to handle the bad news of FERT failures, and I think that's really not fair.
I think that's what Dr. Rohit said. They sit and counsel together. The breaking bad news is like they make the diagnosis with the clinician.
It should be done regularly everywhere, and all the embryologists should be involved with the counseling.
One challenge I face, and I know is that when we tell them to counsel, they use a lot of jargon. Somehow they cannot get out of that love for jargon. Jargon.
Technical terms.
Technical terms.
I'll now actually shift on to the management side. I mean, Vivek, could you give us some management tips how to improve attitude in colleagues?
So attitude, people say that people are born with it. I think it's all a lot to do with how they're motivated in an environment to learn. So it's a lot about the culture also of where they work, the leadership that, say the head of the laboratory or the organization, the direction they give and how they fit into that overall plan, and how excited they are to do that. If they're excited, then they will kind of go in that direction. So attitude, yes, it's something that can be kind of guided. It's something, of course, the passion comes from it. I like the word that you use, passion, because that's something that drives that person to succeed. The need for learning, the need for just not coming to the office 9 to 5, doing your job and getting back. It's working that extra, asking those extra questions. Why, what if, those sort of questions. And then kind of testing and having a strong, not just being alone, but having a strong network to support you in that sense. So a lot of people who are successful are not lone rangers. They're people who are highly skilled at their job. They've got the right attitude. They know where they want to go. And they've got the people to support them to achieve that, because they know their limitations. They know when to say, no, I don't know, right? And then they kind of reach out to people around them, and then they come up with the best solution. So I think that's what we do in an organization, is not just, give the person and make the person run and expect the person to succeed. I think it's also kind of providing that environment around the person to make that person succeed. So that's what we do. Yeah.
One more question. To you only, Vivek. How's putting someone in the firing line change the attitude? Because, I have been in situations where situations have changed the attitude of a certain person. So, if a newbie or let's say a mid-level guy is sent into a difficult position, will that change the attitude? For example, if we have a fertilization failure, the senior embryologist obviously knows how to speak, but how about sending a mid-level or a junior embryologist to convey the bad news?
You have to pick the right person. It's not that you just don't send somebody who's completely incompetent, right? So you have to have some confidence in that person that they can deliver. Of course, you can guide them to do that, but using the line of fire to make them achieve. I think as a senior, one would know exactly whether that you get a sense by the time you're working with this person for a couple of months. You know that you can give them the do's and don'ts, what to say, what not to say, what will trigger the patient. If they have that kind of background, they will be careful not to use these words. They'll use only these words. You can give them a canned speech, but I think you know your people when you set them out for success, or so that they don't mess up. So yeah.
See, it is the sense of belongingness that has to be cultivated in the embryologist. For what I mean to say is, the embryologist should feel in each case, that I am handling something which is not belonging to someone else. Maybe my own relative, my sister, my someone is there who is undergoing the treatment, and I am handling that one. If with this attitude, he will touch those cells, he will never do wrong things. He will be little more cautious, to do the things properly. And in such scenarios, what happens generally is, initially when he starts embryology, at that time he's too curious to know, oh my God, how that got fertilized. Oh my God, it has started cleaving. Oh my God, it has turned to blastocyst. And maybe when the baby comes to him, he may be in his tears to see that, oh my God, this is what I created under the microscope. But this, not only the joy of creation, but this is the sense of responsibility of creation. It should continue, for each case that he's handling. It should not get diluted over the period of time. ये तो क्या है, हो गया, क्या करने का, इक्सी करने का, चलो ठीक है, हो गया, कर दिया. ये lightness जब आ जाता है ना, then you lose that particular, the type of ownership that it should have. And then you start, going a little bit lighter side on that. Now here the thing is that if even a junior person is so passionate about doing the things properly, it depends upon the speaking skills. He may be, be able to convince the patient better than his senior sometimes. He may be he might have handled that situation of the insemination. The senior embryologist must have given him that task of, say, for these 5 cases, you are doing the insemination part of it. And he has done it. So he knows what went wrong. Every time, generally, what happens is, the clinicians always point out that if the fertilizer is not there, then it is the embryologist's fault or the laboratory fault. Please try to understand, the eggs, clinicians say that I have given you 10 M2 oocytes, and that's all. My job is finished. So you give me 10 blastocysts and give at least 2 pregnancies out of it. This mindset should be 10. It is not the quantitative assessment that I have given you this. The M2 getting the M2 oocyte, M2 doesn't necessarily mean a mature oocyte, competent oocyte, cytoplasmically. So all these things we will handle it. So while doing the ICSI, when the junior embryologists also come to know, no, it has got that some problem with the ulema. It didn't get, that funnel shape at all. All the oocytes, majority of the oocytes, the injecting needles went through. And while coming out, the ooplasm started oozing out. Now these things, the clinician will never understand in his life. He will only say that M2 oocytes were there. How come they get degenerated? How come they can become dark? No, you had done something wrong into that one. So these are the things, these are bad things. Okay? And he understands, and he will be able to convey that properly to the patient. That look, your eggs were mature from the nuclear point of view, not from the cellular point of view or from the cytoplasmic point of view. Now these are the details that only an experienced person and the person who has done it properly, he will be able to convince the couple properly.
Just to extend what you said, sir. Now, unfortunately, nowadays, the juniors which are coming into the industry, they just want to do ICSI. Forget about other things, counseling, troubleshooting, management, nothing. They just want to do ICSI or biopsy. So I think there should be a change in attitude for the beginners so that there is a timeline for everything. So just to continue, sir. And what is the role of AI in terms of training?
Well, AI is, no doubt, it is still under the experimental stage, but why I'll tell you, AI has both plus and minus points also. AI will be a very, very useful tool, provided that you provide the information to it correctly. AI is not generating any information. It is compiling the information given to it, and then it is minimizing your task of going through, thousands of cases and analyzing, oh, this oocyte has this much of thick zona. So what was done at that time? AI will remember that and then do it. But provided that you will provide proper information to AI, and then AI can do wonders. But there is limitation, as I talked in the conference. See, nowadays AI is working with the gadgets. Okay, suppose there is a incubator with fixed camera angle into that one, and that is connected to the AIs. Now when it sees an egg inside, okay, at the time of fertilization, for example, I'm just giving you a simple examination. If at the time of seeing the fertilization, 18 to 20 hours after the insemination, from one angle, if the camera sees that there is a single pronuclei, it will send the message to the computer that reject this should not be used for that. But is it the case? Is that the truly single pronuclei? What you can do is, when we do it manually at that time, if you rotate that, then you can see sometimes that the second pronuclei is behind that. AI will not do that. So these are the limitations. The number of blastomere counting also. Sometimes if it is overlapped, then the AI will just see that, okay, how many cells you are seeing? 5 cells are seeing. Oh, so odd number. Keep it grade 2. It will never try to see, the other side of that observation. So these are the limitations of AI. So unless and until you will put at least 5 to 6 cameras and then check everything. But mind it that I really doubt that how many people who have purchased the incubators with the laptop, they are routinely using it for each patient. It is practically not possible. So there are limitations of that also. Manual interpretation, has still a lot of role to play, particularly in ART at present. Yes, as I told you, in future, maybe you get the gadgets or maybe you move towards in such things, you will be able to judge it from your home also.
It becomes more mandatory for embryologists to know the science behind a particular procedure, the biology, how it alters, and know the details of whatever they are performing. Now that AI is there, because over time it will not be the skill but the knowledge you have that is going to be of value when you try to devise, because machine is going to learn what we are going to teach, show the machine, right? So if we are the ones who are going to teach the machine, we better know our subject well. So it becomes all the more mandatory now that we know everything to the finest details.
Right, ma'am. Ma'am, just to continue, is it difficult to train, for taking decisions, especially at times, right? There is single oocyte, and this is just I'm giving a hypothetical situation. Single oocyte, and you want to do ICSI or IVF. I mean, a lot of people have moved to ICSI nowadays, but still, how to train people taking decision under pressure?
Most of us learn it on. It starts with taking smaller decisions, and then over time you gather the experience, and then you are involved in the major decision making. But as an embryologist, we know that we have evolved over the years. Today, decision making under pressure, critical decision making is an important aspect as you grow the ladder. How can we train? I'm not sure how this can be done. But yes, we need to brainstorm and think how this can be a part of our curriculum.
I think I'll add on a bit. I mean, we have in gynae there are about 6 or 7 major emergencies. So we have something called as an algorithm. So let's say PPH, you first palpate the uterus. Then if it is palpable, what is to be done? If it is flaccid, what is to be done? Why can't we have a similar algorithm in embryology? It will make the job so much more easier. So, even if I have not faced a PPH, a severe PPH, well, I have faced in life where, I was in a place called Firozpur. Most of the people won't be able to point out on a map. No blood bank for at least 100 kilometers, and the patient starts bleeding. I mean, there is an algorithm in the mind. You know what to do. You follow the steps, you will ultimately, generally 90% of the time, reach the correct conclusion. Why can't we do the same in embryology?
Definitely much needed so that everybody doesn't go through that long learning curve and learn it as they grow, and we lose on, patient impact. So definitely having good algorithms in place where, we are trained from the beginning to take decisions at the right time and the right decisions. And we also, to some extent, know the impact of those decisions should be the way forward.
I think this is a question for all. Are we ready to take the fresh graduates in the clinic? I mean, this is very tricky question because people are ready. Sorry, ma'am? So because they're coming with a huge knowledge, but zero hands-on training. So how do we train them? Like, are we ready for them? Dr. Rohit,
would you employ someone, sir?
We do have a policy of taking people from campuses, and we've been doing this for 10 years. But then again, we take from 2 specific campuses, so that answers the question. So it's like that.
I mean, that's what I said. When you look at a medical college, what is the minimum competence of this guy. Okay, I'll just, slightly extend the question. This is to the industry people. Do you think a poor embryologist affects your business too? Shilpa and then Vivek.
So I think right from the time I have been inducted into this business, I think embryology has been a very important, stakeholder for us. Embryologists have been very important stakeholders for us because we market the gonadotropins, and basically the gonadotropins job is around embryology, right? And not so much related till the live birth, right? Because there's lot many factors involved. So for us, I think we've always felt that this is a very, very important stakeholder, and it is something that is important to the industry all the time. Yeah.
Vivek, any additions?
So we view both the clinicians and embryologists in terms of the final outcome. From the clinician side, giving the right dose, and then from the embryologist side, making sure that the work that they're doing behind the scenes, the drug has actually done the work that it has done. And for us, it's very critical that the embryologist sees, the endpoints where the drug has acted, what are the expectations, and, provide feedback wherever that is required, because that, of course, will impact whether they find the drug better than another drug that they've used, whether they're willing to switch to something else, assuming they would get a better result from another drug. So it's very important for us to get feedback that, this is what they did, this is what they saw, and work together with us on that aspect. It's not just about switching, and then coming back saying we've tried 3, and then I think this was kind of the best one. It's really understanding how to make one drug, kind of more successful or successful in their practice by continuous feedback. That's how we view it.
Yeah. Thanks, Sudipto. A small question to you. Have you ever got a feedback from any of your, product users, saying your drug is not working, and where the blame possibly lies at the embryology end?
Sir, never directly, but yeah, but I'll be honest, because I think, sir, I think what my colleagues have also said, I think largely embryology is that part of the entire, I can say, the treatment journey, what I think ma'am has also mentioned. It's a bit subjective, and at the same time, it's still based on very hardcore objective parameters. So sometimes it's a bit difficult to strike the right balance, and that actually creates uncertainty. So when it comes to possibly something or an outcome that you cannot quantify, you cannot describe, it is always that uncertainty that people look at, that possibly something went wrong there. And I think this is where probably, when we consider clinical and the embryological part, it's probably that lab part, that experimental component becomes very, very critical. Because drugs, I think, probably a limited duration of stimulation, I think patient profiling, the extent of discussion we have with doctors, I think we understand that pretty well. It's more identifiable, more quantifiable, more seen, and something that's measurable. I think what happens on the lab side, that is the part where possibly, that element of unseen or the uncertainty comes in. So I think for us, very critical that embryologists are involved. Yeah.
Well, moving on, this is to Dr. Akash. Are we really ignoring individual training styles, or how is it? Like, how do you train them? Like, is it a blanket rule to follow certain rules, or you're going to customize them according to the candidate?
The problem which comes over here is we can customize, but any lab, not just embryology lab, has something called as SOPs, standardized operating protocols. So
fortunately, we don't have it for training.
Training, yeah. So we need to fit in. Otherwise, how do you assess? That's the first thing for majority of them. But then one size fits all never works. And since you are in India, how can we leave Bollywood or cricket out of it? I remember that line from MS Dhoni movie. Dhoni, if all of you may know, has a very unconventional style of playing, right? He does not fit into the categorical of taking the stance or hitting. So in the movie, they show he's not good. He does not follow the regular rules as such. So there's a question asked by one of the selectors. Is his style not good, or is it unconventional? That's what we need to differentiate. Is it bad, or is it unconventional? Unconventional, we need to fit in. Just because it's unconventional, we can't leave it. So one size fits all definitely would not help for training styles, because some person may be very good at, say, vitrification and warming. They may have just excellent skills. They may pick it up in a couple of days, but they might take too much of a time for ICSI. So we just can't have one style fit all. So for me, I don't.
Unconventional but effective. That was the line.
Yeah.
Okay. This is to the embryology side of things. There are so many equipment. For example, ICSI machine itself, there are about 3 or 4 micromanipulators which are available. Is it possible for one person to get trained on all? Or is there a difference between, how can you actually, the embryologists keep shifting from one place to another, or possibly do embryology at more than one center? The equipment might not be similar. So how do you overcome this?
Well, theoretically, it is possible for one person to, get trained in 2 or 3 different machines. the question is it required? First thing. Because if a person is attached with one center, if he has established everything in one type of machine, there is practically no need for him to again go and learn on a different machine unless the center decides to get that another machine. Because once you are used to that machine, you know, over the period of time, it so happens that you are aware of each and every nut bolt of it, and then the troubleshooting becomes much, much easier. Not only that, the skill level improves. Because of the practice, obviously, you are working on that machine for 20, 25 years. So now you can even sleep also, you know, you can handle the things. You know what the zero error is. You know what the right side and left side, how it moves. You know how to push it, how much to push it, what should be the pressure of your hand. Everything you had is in your brain. So it is fit. So it is better to stick to that one unless and until you are visiting embryologists, going to different places, and different centers have different machines. Then truly you have to be master of all these things. There is no any alternative, because you have to give results in all the centers. Though your responsibility is more there, and you should learn all those things. Theoretically it is possible. Practically it depends upon the situation, whether you have to learn or you should not learn.
Yeah, well said, sir. Basically it is just knowing the machine. Maximum it is like automated or semi-motorized or manual. Otherwise it is one and the same, right? Yeah.
This would be the last question, and I would expect an answer from all. What would a 21st century or next gen embryology training lab look like? I'll start with Dr. Rohit.
You showed in your slides, maybe conceivable in every clinic in every city of the world.
Thank you. Sudipto.
Maybe semi-virtual with 3D, maybe some kind of visualizations that can actually make troubleshooting and hands-on experience much more quicker.
Shilpa?
A little more AI enabled, and maybe, help with those critical situations and simulations to work under high pressure.
Yeah, simulations of critical situations is a good one. Vivek, any additions from your side?
I think in one of your slides, you made a laundry list of all things that need to be, that an embryologist needs to do. I think putting that in the overall curriculum and giving them a nice 360-degree view before they leave, I think that's the future. It's not yet addressed yet. Yeah. Yeah, but that's what should be in all trainings.
Thanks, Vivek.
I think that's something which gets them ready to be effective and holistic, ready in the real world.
Okay, adaptation to from let's say theory to practical.
Well, if I would be in the 21st century's academy, I will enroll myself into that one. I will expect that I should be, I should get the training from a trained embryologist in different aspects. For example, rather than one embryologist teaching me all aspects, let the person who is expert in that particular thing, embryology, how to do ICSI, how to do vitrification, you call that master and teach me. I will be happy.
Diversification of source and integration into one. Yeah. Varsha.
I think it should be able to integrate 3 sciences: biology, computers, and information. Secondly, the newer programs should also look at integrating the other branches, the so-called super specialities of reproductive medicine, which include also reproductive genetics, immunology, regenerative medicine. An overview of all that would also be helpful for the embryologists, because going forward, they will
actually become run-of-the-mill also, I guess. Paul?
Yeah, I think many things have been mentioned now with respect to the needs in such a laboratory. I think we have to think out of the box also and include much more new technologies, because I think in such an embryology laboratory in the 21st century, there would also be a need for qualifications on gene editing, even maybe epigenetic editing for correcting different diseases. That's on the brink of becoming reality now.
The laws have to change for that, I guess.
I assume so. So, because when things become more safe and more tested, I think there will be chances of using gene editing and even also maybe epigenetic editing for the clinic.
Yeah.
So that's something also to be embraced.
Lotte?
I fully agree with everything we heard so far, and with the new technology, I will take a step back and said it should definitely include the human factor. Still somebody who can inspire, motivate, and remind the human factor why we do what we do, and not forget the more advanced technology and the more advanced we get, there are some very basic common knowledge thing. When I go to consult, I still see is forgotten in the chase of something more fancy or more advanced.
Well, that's the end of the panel discussion. Thank you all for active participation and
Thanks a lot, everyone. I mean, it was a pleasure and to actually conduct it, to moderate it. And believe me, most of the questions were extempore. So it was even better that way. Yeah, thanks a lot. It's an honor to be here. Firstly, thank you, Professor Renu John. Thank you, Sanket. And thanks, 80% or 90% of the people whom I invited actually came down, which itself is so encouraging for us. Thank you. We need your blessings to take this ahead. Sorry? Thank you. We'll have the vote of thanks. I'll call the MC over. But before we actually disperse for tea, I would request everyone to come down for a picture after the vote of thanks.
So, thank you, sir. As we approach the concluding segment of today's event, it's my pleasure to introduce Mr. Sandeep Tote, a distinguished professional in the field of assisted reproductive technology. With a vast experience in IVF laboratory operations, training, and embryology advancements. Let's welcome Mr. Sandeep, sir. I invite Dr. Renu John, sir, for the concluding remarks and for gifting him a memento.
Thank you all the dignitaries and invitees to come and help us to improve what Professor Renu sir, Dr. Sandeep sir, and as a team stake we are planning to start. So we need all the suggestions, all the things to improve the training in the field of the embryology. So we are thanking you all for the coming and joining us for this event. I am welcoming Professor Renu sir.
So maybe we'll have some quick mementos before we disperse. So, yeah. Can you just...
I request Dr. Sandeep Taute to give the mementos and the scroll to our dignitaries. So I invite Dr. Sudipto Chatterjee to come forward. Dr. Shilpa Arora.
Come, Shilpa. Yeah, it's okay. She doesn't know.
I invite Mr. Vijay Soros.
Vivek Soros.
I request Dr. Sanket Dhumal. Dr. Rohit Kudkutia. Dr. Varsha Roy. Dr. Akash Agrawal. And Dr. Vijay Mongolia. And Mr. Vikas Verma.
Thank you, sir. Now I invite Dr. Renu John, sir, for concluding remarks, summarizing the key insight from our discussions and emphasizing the path forward for skill development in ART.
So, good evening, all of you. Heartfelt thanks from the center to all of you to be here today. I think we miss Dr. Alex here. So a lot of this discussion started with Dr. Alex and Dr. Sandeep probably a year and a half ago. Several night hours, Google Meets have been done. A lot of these, even the fine points of the lectures to be delivered has been recorded or in the process of being recorded by Sandeep and Dr. Alex. So I would really thank both of them to sow the seeds for creating this program and this center. The next important person in this show is Sandeep Tote. So I think all of this realized a few months back when we met him at the embryology conference. We came forward voluntarily and said, why not, let us do it, and he came forward to put the devices and equipment together and support this effort. So thank you so much. And the last 3-4 days, I think his entire team was working tirelessly overnight, getting the center up. Then the entire CfHE team, thank you to all of the people who have been with us for getting this center up. So a quick word about IIT. So I have been asked, like, why are you here? So why are you here for this particular program? So I think the 21st century questions answer most of that concerns. So we have been here for a while looking at creating impact at the last mile, creating new medical devices, innovative thoughts, creating new products, startups, and we started this journey by upskilling people in the area of medical devices and biomedical engineering. So 15 years back, IIT Hyderabad created this new department of biomedical engineering. Our whole focus was to create innovative medical devices, expand in the areas, and create in-house expertise in various areas of biomedical engineering. So if we have people like Suhail here who are looking at modeling cells for modeling cells, or creating or studying the microenvironment of cells, in silico modeling to predict things. We had faculties who are working at cell biology, molecular level, molecular biology, looking at the genomics of biology, a lot of bioinformatics with the department, genomics analysis. We have a number of imaging instruments and microscopy being developed from the department. I think there's a strong biotechnology department, biomedical engineering department, and the center has been supported through all the faculties across various disciplines. So that is the only reason why we are here in this platform.
Hello?
Probably if we can look at the next generation of IVF technologies, how we can improve the medical devices for better outcomes, for better performance, how we can predict the outcomes of what we are doing, how we can get better empathy delivered to the patient. So this is all what we have been doing, and we would love to do this again and take and create this impact. And for each of you, you have been here. I think I owe to Sandeep and Alex for choosing you here. And this is only a beginning. We really want you be here as part of the center, as part of the program. So the whole program has been minuted, and we will reach back to you. So what the program needs, or what the center needs from a clinical perspective, what the program needs from a clinical embryology perspective, or what the industry is looking at when such a program is hosted from IIT. So we need all these inputs. We have captured whatever has come across, but we need more thoughts into it. And we are ready to offer a program which is really for the next generation. It would be really embryology 2.0. That is the assurance that we can provide. Thank you so much, and let's join outside for a quick short tea. Thank you very much.